right, so we're going to start number 2 here. Oh, number 2. This one, I swear I thought about this problem before. Oh, wait a minute. Isn't this the first problem that one of the problems we did in accelerated systems? Or did I get rid of that one in yours? I got rid of that one in yours. That's right. That's right. Sorry, the honors did it as their first problem, but... Yeah, some people use those, yeah. So like on the in-class problem next Monday, you would use sheets like that. That would be used for a non-forces one, where your Y is not a force diagram, but writing. That's why you have the lines there to help you. You're tracking as you write sentences. All right, so we're going to do number 2 here. And I didn't open up the thing. So let's pause for a second. All right, so number 2. Alrighty. So let's see, I got a box with a rope. Attached to it. It would have a weight and a tension. And I think they tell me it's accelerating if I'm correct. Yep. So there's my correct force diagram for this situation. All right? Which leads me directly to my free body. Big old dot replacing my block. F sub G, tension, acceleration. Now, because everything is in the Y direction here, I don't think I need to redo it in the Y space. All right? So I'm just going to forget about doing another free body. It's really nothing to break up. And start in with the sum of my forces in the Y direction equals F A Y. All right? I have 2 forces. Which way do you guys want to call positive? So I've got, oops, sorry, this should have been F sub T. Sorry about that. That's right on my part. So I'm going to write F sub T minus F sub G equals M times A. And A is positive because I drew it positively. I know the mass. They want to know the tension, force from that. So I'm going to rearrange this so I have the tension equals MA plus FG, which means the tension equals MA plus MG, right? Because my weight is mg. Right, I could rearrange it to make it simpler for myself, A plus G, or I could just substitute in at that point or this point, either one. And so I put in my M, which is 4.8. I have 4.8 kilograms times, I think that was 2 something for my acceleration, 2.1 meters per second squared, plus G, which is 9.80 newtons per kilogram. I'm assuming I'm on the planet Earth. And I do my math, which would come out to be 4.8 times 2.1 plus 9.8. 57.1. 57.1 newtons. Kilograms times that whole message. Hopefully that's it. That's it. All right, so number 6 here. Very similar to number 5, except this time you're pulling up on the rope. And hopefully when you did number 3, you noticed that when you pushed down, you increased the normal force, which increased the friction here. And then when you pulled up, you decreased the normal force, which in turn decreased the friction. But at least you saw in number 3 about increasing the normal force pushing down and decreasing it by pulling up. And then in 5, they have you pushing down on this block. In 6, you're pulling up on it. All right? So I'm just going to grab this image so I don't have to try to redraw it. We're on 6. All right? Number 6. So in number 6, we're going to have the weight down. We're going to have a normal force up. I'm going to assume that there's a frictional force in this direction because they tell me about the coefficient of friction, so there must be a frictional force, right? Why else would they tell me about it? And the difference between the scenario for part A and the scenario for part B is that in A, it hasn't started moving yet. So the type of friction we have is static friction because the two things aren't moving relative to each other. And in scenario B, it's just started moving, so you have that kinetic friction rather than that static friction. And as you hopefully notice, the coefficient of static friction is a lot higher than the coefficient of kinetic friction. So it's going to it's going to have a larger frictional force before it moves than after it moves. Kind of like this is exactly the scenario looking at your shoe that we did in the mini lab last Friday, except this time, rather than pulling in a straight line so you get all of that, they pulled upwards, which made it a little more complicated situation. All right, so very similar in thought process to that problem we did. And then, of course, the one I didn't redraw was this F here. All right, so that would be your correct one. If we're looking at the second scenario, you'd have the exact same free body, except you'd have an acceleration in this direction and a different frictional force. So this is only for part B that you have this acceleration. All right? So I'm kind of taking the easy way out. So let's do part A first. So in part A, no acceleration. And then I need to do my component drawing over here. They tell me, let's see, that's an angle of 25. This angle is 25 degrees. And so what I need to do is my horizontal and my vertical. My vertical would be F sine 25 degrees. My horizontal would be F cosine 25 degrees. All right? Now, put those into X and Y. Okay, if I scroll down to the X and Y, or do you guys need more time? You good? Okay, so in the X direction, I have F cosine 25 degrees, and I have frictional force. In the Y direction, I have the gravity down, F sine 25 degrees down, and normal force up. That should be everything. Sign goes up. Thank you. Because I forgot which one I was doing. And I just erased the pen, which I didn't want to erase. Thank you. I was thinking in the other case where it went down. So there. That's why we caught that now. Otherwise, we would have ended up doing problem 5 rather than problem 6. That wouldn't have been too bad. So, I'm assuming you guys want to call up and to the right positive, right? Do I start on the x side or the y side? X, okay. So in the x, sum of the forces equals ma. So I add up all the forces, that's going to equal the mass times acceleration. I have negative frictional force plus F cosine 25 degrees equals m times 0. On the y side, I can't really go any further there. Same equation. It's nice only having one equation for this whole chapter. I have force normal plus F sine 25 degrees minus F sub g equals m times 0. Now, they want to know what F is. But in both sides, I don't know the normal force over on the y side, on the right-hand side here. And I don't know the frictional force on the left-hand side. All right, so I'm kind of stuck. What I need to do, what I'm going to do is I'm going to try to substitute in for those and try to bring these two equations together. So what I'm going to do, let's see. Put into the what thing? Oh, Wolfram? Yeah, we could do that. Let's make sure that we find values for our trig functions though first, right? And we know, and let's break this down slightly further. We're gonna have over here, whoops, negative mu force normal plus F cosine 25 degrees equals 0. Over here, we're going to have force normal plus F sine 25 degrees minus mg equals 0. Right? Just trying to get things down to maybe what we know, what we don't know. Well, how did I do what? Because I looked at my equation sheet, and I noticed I have 3 identities on there. One for weight, which says that F sub g equals mg. One for frictional force. Remember we did that lab on it? It was right on the front sheet of the lab. You and I spent some time yesterday going through that exact equation. Friction force equals mu force normal. And then there's the third one about springs that we haven't talked about. Well, you read about, but we didn't talk about it. So that's how. They're right on the equation sheet. Let's put in what we know. It's not moving, so we know it's the static coefficient. So 0.1. I don't know force normal. I don't know F. Cosine of 25. I need my calculator. Let's see. Cosine of 25. 0.90631. 90631. So 0.90631 equals 0. And over here, I don't know normal force. I don't know F. Sine of 25. 0.42262. 0.42262 minus, I think I know M, don't I? 30 for me. 30 kilograms times, I'm running out of space, 9.8 newtons per kilogram. Sorry. That's just G over here. All that equals 0 also. Now, I would, remember how Wolfram sometimes doesn't like weird variables? So I would change it to X and Y. So what I'm going to actually put into Wolfram, I'm going to write it out here. On the green side, I'm going to put in negative 0.1 Y plus X times 0.90631 equals 0. And on the red side, I'm going to put in Y plus X times 0.42262 minus, I think I'll, 30 times 9.8 equals 0. So that's what I'm going to type into Wolfram. Well, I could also have done algebra and substituted in for each side, right? But let's give this a try. So I'm going to go down here to Wolfram, start typing. Negative 0.1 Y, negative 0.1 times Y. Why did I pick Y? Why not? Plus X times 0.906. 0.90631. That all equals 0, comma, my other equation, either that or multiplication symbols. 42262. The asterisk, comma, space. Yes, you do. I'll make mine larger so you can see what I'm typing. How's that? Better? Of course, as soon as oops. Minus 30 times 9.8 equals 0. So it gives me an X and a Y, and I care about, let's see, I care about my X. So my X is 30.994. If I was to round that, I'd round that to 31. Let's see if I got it right before we go. I'd round mine to 31.0 because it was 30.994. See if I got it. Mine came out correctly. So I should so remember to keep that. Well, that's where we're going to do the other half of the problem now. So I came up with my F equals 30.994 newtons using Wolfram there. All right. Well, let me do the second half, and then I can come and look at your work individually and check that you've plugged in everything correctly. Okay. What is its acceleration once it starts to move if that force is maintained? So in this case, now, really the only thing that's changed about the whole scenario is that it's the friction, once it starts to move, the frictional force will be reduced. The normal force isn't going to change, F isn't going to change, the gravitational force isn't going to change, but we're going to accelerate now. So we would have an acceleration in this direction, and that would be show up over here. Oh, this is kind of nice. We figured out our normal force, right? So we don't have to recalculate that. Because if you remember your Wolfram stuff, it also told me that my normal force, my Y value, was my Y value was 280.901. Careful with the air there, don't blow yourself up. .901 newtons. So that's kind of convenient, because what I'm looking at for a free body now, let's extend this page, is I'm looking at this, F cosine 25 degrees, frictional force, and it's accelerating that way. So if I do the sum of my forces is MA, they want to know A, so I would have negative frictional force plus F cosine 25 degrees equals M times A. So I'd substitute in here negative mu force normal plus F cosine 25 degrees equals M times A. Oh, I could divide both sides by M, couldn't I? And that would leave me with just A on that right-hand side, right? So let's see, what do I know? I know mu, it's 0.03. I know force normal, 280.901. Remember, it's just started moving. So it's switched from static friction to kinetic. Once it's moving, it's kinetic friction. Plus F, which, what did I, 30.99 something? 994? I would use the exact number so you don't make any mistakes due to rounding. And my mass was 30 kilograms. All of this equals A. Now I just plug it in my calculator, right? Yay! Make sure that works. So, let's see, calculator-wise, figure that out. Big parentheses. .03. Oh, that should be negative, sorry. Negative 0.03 times. You shouldn't have. Good. Check your order of operation. That seems be a lot of people's problems. No, you didn't. Yep, it's not going to be large. I get 0.6554. See if that's right.